Hey everyone, this is Greg with Science Studios Minute Science. Did you know that there is a moon actually in our solar system that is a lot like Earth in more ways than one? Now this moon is actually a fairly big moon when you compare it to like our moon orbiting Earth. This moon is twice the size of our moon, and it also has an atmosphere. It's actually the only moon in the solar system that we know of that has an atmosphere. If you haven't figured it out by now, the moon is Titan, and Titan orbits Saturn. Titan has some very unique characteristics. Cassini made its first official Saturn flyby in 2004, and at around the same time that the probe was taking pictures of Saturn, Titan, Saturn's largest moon, was catching the satellite's eye for more than one reason. The first and most obvious reason is the fact that Titan has this glow. It's just hazy. And no other moon in the solar system has this kind of haze, like these clouds that cover its surface. Only planets are supposed to have those things, right? I mean, a moon doesn't have enough gravity to pull gas around its center. Like, what's going on here? Further investigation led to the discovery that Titan actually has liquid on its surface. It's actually the only other object that we know of that has liquid on its surface. The Mars discovery that happened recently, I want to see video proof of that, okay? We actually dropped a probe on Titan and found liquid methane. So yeah, that's actually what the liquid was on the moon. It was methane, but it was so cold on Titan that the methane, which is normally a gas here, was a liquid and is still a liquid on Titan. Another characteristic of Titan that makes it very unique and much like Earth is the fact that Titan actually has active tectonic plates. If you remember from one of our previous Minute Science episodes, we talked about tectonic plates and how those on Earth are constantly moving back and forth. They're shearing each other, pushing against each other, and pulling apart from each other. Well, the same processes are actually happening on Titan, but for a different reason. So Titan doesn't have a very hot radioactive center, not like Earth does. Very heavy radioactive elements didn't make it that far out into the solar system when our star was first born. What Titan has that Earth doesn't have, though, is a large partner, in this case, Saturn. And as Titan orbits this planet, Saturn's gravitational pull basically churns all the rock that's inside of the moon. And this creates a lot of heat. A lot of friction is generated, recall from one of our other Minute Science episodes. And that heat basically moves these rocks all around. And eventually these rock faces basically led to the creation of tectonic plates. There was so much friction in the moon that rock faces actually crystallized and formed solid plates. So Titan has many oceans, sounds a lot like Earth, and Titan has active tectonic plates, like Earth. These are the only two places that we know of that have active oceans and active tectonic plates. But perhaps the most obvious trait of them all that makes Titan so similar to Earth is the fact that Titan has a very dense atmosphere. But it's the composition of the atmosphere that makes it so like Earth. In Earth's case, nitrogen composes about 78% of its atmosphere, but in Titan's case, nitrogen composes 98% of its atmosphere, the remaining gases being hydrogen and methane. Now obviously this atmosphere is not conducive to life as we know it, but that doesn't mean that life on Titan couldn't have formed under different conditions. Life here on Earth generally respirates oxygen, but life on Titan could utilize methane, maybe even hydrogen. It's possible. We don't know if it actually is the case, but it's possible. The cool thing about science is you really can't come to absolute conclusions until you've analyzed everything about what you're studying. And the thing about space is it's huge. So we'll never be able to fully accept the fact that we're alone, or maybe that we're not, until we've discovered every planet that there is to discover, and I guess in this case, every moon there is to discover, to guarantee that life doesn't exist. Or does. Look, all I'm saying is that if a moon in our solar system has an atmosphere and lakes and rivers and streams and geysers and tectonic plates and a dense atmosphere, what are the odds that just other moons out there are possibly able to support life? For all we know, there could be planets out there made of cheese and other planets made of like sugar or something. I mean, we don't know. And until we discover, or probably in this case, don't discover planets made of cheese and sugar, we can't say for certain that they don't exist. And that's the beauty of science. In particular, that's the beauty of astronomy. This is Science Studio. Thanks for learning with us.